Hey, and welcome back. So now we're going to do some testing. We're going to take some measurements, voltage measurements, things like that. And I'm going to compare them to the notes that I made before I changed anything. So we've got all of our tubes in, our two 6L6 tubes, and our two preamp tubes / phase inverter. I'm really not sure how this circuit exactly works. So anyway, I'll leave my notes over here on this side where I can see them. I've also got a chart here on the specific tubes that we're using as far as the power tubes, the 6L6. And so, it shows us the like pin 8 goes to cathode and the suppressor grid or G3, grid 3. You got grid 2 in the middle, screen grid, and then there's the control grid, grid 1. Here's cathode, there's a plate, and of course our heater, two heaters here. Every type of tube is a little different, and thankfully there are similarities across certain ones. So anyway, let's get our amp safely hooked in. We're going to get our safety circuit ready. Oh, and I bagged off all of the old capacitors and resistors, even the fuse that was way above the actual rating for this amp. I'm just going to keep these just for keepsake. But anyway, looking good in here. We got our 8 ohm resistor load up here. Maybe right out of screen, but there it is. So yeah, let's plug in our amplifier to our variac again, and let's see. Can you see the variac? Yeah, there it is. I'm a little worried that my light here is actually causing distortion on the video. And if that's the case, I apologize. I've got to have some light to, really see what I'm doing. But I wish this looked better for y'all, but I'm doing the best I can. All right, now what we want to do is just some simple things, really. I want to test the plates, which is pin 3, which will be here and here. I want to see if there's still 447 volts DC like there was before I did all this. And I don't guess I can check the voltage on the cathode, pin 8 here, because I don't have a 1 ohm resistor going from the pin 8 to ground. I haven't tried to, but anyway, let me back up. I have not tried to measure voltage on pin 8, which is the cathode / suppressor grid, with the power tubes in. Now, with the power tubes not in place, there was no voltage on these 2 pins. But that was probably because the tubes were not in there. Now, we're going to put our voltmeter, since we're going here, let's check pins 3 first. Well, that's the plates, okay? That's gonna be DC, and we're going to be looking for like close to 500 volts on this amp. So we're going to put our voltmeter on 1000 DC. I got my ground tap down here to the chassis. Now, since we are running such high voltage, we're going to use this adapter to go from the pin or the probe of our meter turns it into a clip. And we're just going to clip to our pin 3 on our power tube, on this tube here. because that's such high voltage. I don't want to be poking around with that thing in my hand. It's not going to shock me unless I make contact, but you never know, something can go wrong. Or worse yet, I could even, make something arc across here, so we don't want to do that. Now, let's hook our orange, at least on my bench, I got an orange safety plug. I know when that's plugged in, that means I got juice to my safety circuit and to my variac. Excuse me. Now, the amp is off. Double check, I do have a load on here. Okay. So let's turn our variac on. And I gotta have at least 30 or 40 volts for this meter here to even come on, be about 30. Now watch our voltmeter here. Now the amp is receiving this power. And I'm gonna go up to about 100 volts. Okay, let's flick the switch. 360, 370 volts on our plate. So that's good. We've got good. So, all right, so let's go up to standard 120 or at least 117. I'm going up on the variac. You see in the rise here on the meter on our plate. And now my current bulb over there is going off. And actually, it won't let my variac go above 115 volts. So something's taking in that power. Okay. Let's back it back down to about 80 volts. And you see the voltage dropping? That's a good sign. All right, now, don't touch anything in here. We're just going to go to the plate of the other power tube. It should read about the same. So let's go back up on the variac. Don't rush it, just let it happen. Yeah, I get about 105 volts and then my safety light over there starts going off. So again, I can't get it above 116 volts. So something is taking that extra current there. But what gets me is we're still under an amp of current. Even at the worst, we're not even up. We're only at 0.7. So I don't know what's going on with that. 45 watts. Okay. And don't ever touch the chassis with both hands at the same time. All right, so our voltage is down. And you want to also play it safe. See what our yeah, we got 4 volts here on the capacitor. We can quickly get that down to 0. just by going to ground. Let the resistor take the load. Now it's down to nothing. So, okay. So what we can do is let's try the cathodes. Let's just try that. I don't know if we're going to get a reading or not. Now what I can do is place it right here. Both of these tubes, this tube's socket lug is feeding pin 8 on this other power tube. So let's see if we've got anything. See, I don't think you can measure this. No. And I really can't explain to you why. I know there's a simple explanation. But this is a cathode biased amp. So what's happening is, let's see, there's no voltage there. Let me cut the variac off so we don't have power going to this. What's going on, folks, is this power lug closest to you that you can see there, it just goes to ground. Okay. The other side of this resistor goes to pin 8 on this power tube, and this blue wire feeds pin 8 on the other power tube. And that's how we know this is a cathode biased amplifier. Now the question is this resistor, is it really the right value or the best value? More than likely the factory played it safe. But so, you know, the value of this resistor could be played with a little bit. Like we could try, I don't know, a 400. I mean, I don't really know. And then this thing may be dead on. But in order to find out for sure, I've already placed an order. I've got some solder lugs coming in with the little star washers, the screws, the machine screws, and the machine nuts. That's going to allow us to, and I've got some 1 ohm, I think they're 2-watt resistors or something like that. They're really good. And what we're going to do is hook those 1 ohm resistors to number 8 to the solder lug, which is going to be connected to ground to our chassis. And when we put our voltmeter across there, we're going to be able to read whatever we're getting there. We're going to be able to read it as the actual milliamps, I believe it is, or millivolts, one of the two. So these 6L6s are designed to operate at a safe bias level, and and I'm not sure what that is offhand, but I'll look it up. So we just got to make sure, you know, it's one of those fine tuning adjustments to where we need enough negative bias voltage to where our tubes run healthy, but we don't want to run them too cold, nor do we run them too hot. We can check our screen grid, which is pin 4. We can check that. So let's cut the variac back on. I'm just going to set it to about 100 volts. All right. So we're still on DC. I don't have the amp on yet. Let's put we already got 11 volts on our screen grid. So yeah, healthy 372. All right, let's cut that off. More than likely it's the same. Well, why is that one dropping? So that could be an issue with the tube. The tube in this socket here, I'm suspicious of it being microphonic at the very least, and I think it's got other problems. Okay. Just watch what happens when we go back up to pin 4 on this power tube. We'll get a much healthier voltage. So, it was actually drawing some of the current away through my variac by trying to measure this other power tube. So that's interesting. Okay, now let's go to AC, and we're going to put it on about 20 volts here because we're going to measure the heaters. Now each power tube has got an AC AC, let's see, what pin is that? Pin 2. So that's right here. And that is for the heater of the tube. So we're going to start down here on this suspicious tube. And I'm getting almost 3 volts. All right. Let's try up here. Pin 2. Looking good there. And it would be a little more, but I can't cut it up much more without the safety bulb going off. Okay. So don't know what that's about. Let's see, let's get that voltage out of there. So that resistor soaks that extra voltage up right off the bat. And no sparks. And you gotta watch it sometimes. These capacitors will charge back up. You see that? Even after you drain them. So what can be done there while it's still at a safe level, you just put that on there and just let me hook it over here. Hook it to ground. And don't worry about it. Alright, we don't want to be on here with the heat too long. We don't want to damage the speaker. Let me go down to 100 volts. Now, I'm going to cut the amp back on. No, it didn't register. There's our sound again. I may be going to the volume pot. All right, let's switch to DC. No, there's no AC on the chassis. There's 3 volts. But okay, notice this. You see which this knob. I think this is the volume. We may have DC going to our volume pot. Go there. Probably a small amount. Because a small amount can do this kind of damage. Could it be a negative voltage? I think. Well, the tone, treble works, bass works. If I could just get this fixed, it would work. How about that, folks? Now, it should have AC, slight amount. Yeah. Okay. No DC there. The only other one there. Well, I'm not getting anything. Let's try this one because that also goes there. You know, it's almost like something's not grounded. I could have sworn it was DC, but we know the bass works because it gets boomier and it gets brighter, the treble. So the problem is where the volume hooks up. Just exactly where, though, I have no idea. I mean, could it be in a power tube, or could it be in a preamp tube? I don't know. But we're further than we were the other day. So